Now in this question, mass percentage of benzene and CCl4 is asked, and you are given the masses of benzene and CCl4. Here 22 gram of benzene is given to you and 122 gram of CCl4 is given to you. So that total mass of solution, it will be the sum of mass of benzene and CCl4. So total will be 144 gram. So that the percentage, mass percentage of benzene, that will be mass of benzene upon total mass of solution multiplied by 100. So it will be 2200 divided by 144. So that the answer is 15.27%, and the percentage of CCl4, it can be calculated same way. Mass of CCl4 122 by 144 multiplied by 100. Answer is 84.73, and the total percentage is 100. So that another way we can calculate 100 minus percentage of benzene. By this way also we will get this answer. Question number 2. Here, mole fraction of benzene in solution containing 30% by mass in CCl4, that is asked to you. So the CCl4 is a solvent and 30% is of benzene. Here again same the compounds are given to you, but the proportion is given already 30%. So now the meaning of 30% benzene in CCl4, it is in 100 gram of, generally percentage is found based on 100. So in 100 gram of solution, 30 gram of benzene is mixed, so that mass of CCl4 will be, it's a solvent and it is mass of solution minus mass of solute, that is 30. So it will be 70 gram. So that on the basis of it we can calculate number of moles of benzene and number of moles of CCl4. So mass of benzene is 30 divided by 78. Here 70 divided by molecular mass is 154, and by division we are getting the number of moles. Here 0.38 and here 0.45. So that the total number of moles of solution, it will be 0.38 plus 0.45, and by addition we are getting 0.83. So that the mole fraction of benzene that is asked to you, it will be number of moles of benzene divided by total number of moles of solution. So it will be 0.38 divided by 0.83, and by division we will get the answer 0.457. Next, Calculate the molarity of each of the solutions. 30 gram of CO NO3 twice 6H2 in 4.3 liter of solution and 30 ml of 0.5 molar H2SO4 is diluted to 500 ml. Mass is given to you and volume is given to you. So first of all, the molar mass of solute, that is CONH3 twice 6H2O. This 6H2O is a crystal water. Okay. So molecular mass of solute is 290.7 gram per mole. See, cobalt has 58.7, then nitrogen 14 and 3 oxygen, and it is multiplied by 2 and then 6 into 18. Okay, so we can calculate very easily. So the formula of molarity, it will be mass upon molecular mass into volume in liter. So that the mass is 30 divided by molecular mass 290.7 and volume is given to you 4.3 liter, and overall answer will be 0.024 molar. Now next is 30 ml 0.5 molar solution already is present. Okay, and it is diluted to 500 ml. So what does it mean? It means initial volume is 30 ml and by addition of water total final volume is 500 ml. So that simple formula is applied, M1V1 equals M2V2. Here this is initial condition. What was the molarity and volume? And this one is the final condition. So initial molarity is 0.5, V1 is 30, M2 we want to calculate, and final volume is 500 ml. So that M2 is 0.5, 30 by 500. So overall answer will be 0.03 molar. Mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. So here molality is 0.25, molecular mass of urea is 60, and the mass of solute is given to you 2500. So simply formula of molality is applied. Mass of urea is asked, multiplied by 1000, M2 molecular mass of urea into mass of solvent. So that W2 equals molality into M2 into W1 divided by 1000. So that molality is given to you 0.25, M2 60, and W1 that is 0.25. Sorry, it is 2500 and it is divided by 1000. So by calculation we are getting 37.5 gram. Next, calculate the molality, mole fraction of Ki. If density is given to you 20%, W by W aqueous solution Ki, and it is 1.202 gram per ml. Now, first of all, we have to write the meaning. 20% mass upon mass. That means 20 gram of Ki is dissolved in 80 gram. Actually, percentage is calculated based on 100, but mass of solution is 100. That means if 20 gram solute and 80 gram of water, then total sum will be 100. That is the mass of solution. So here we have written directly. And the molar mass of Ki, it is 166 potassium, 127 and 39 and iodine 127. Total sum is 166. So molality is W2 1000 divided by 166 multiplied by 80. W2 is 20 into 1000, 166 and 80, and final answer is 1.5 molar. Now molarity can be calculated by many ways. See, density is given to you, but here we will apply a shortcut: percentage W by W into density into 10, and overall it is divided by molecular mass of solute. W by W is 20, density 1.202, multiplied by 10 and divided by molecular mass 166, and the answer is 448 molar. Now third thing is the mole fraction of Ki. So for that, number of moles of Ki, that will be 20 by 166. Answer is 0.12. And number of moles of water, it will be 80 by 18. Answer is 4.44 mole. Okay, so the mole fraction of Ki that is asked is number of moles of Ki upon number of moles of Ki plus number of moles of water, and answer is 0.12, and the sum of 0.12 and 0.44, it is 4.56, and by division we will get 0.0265. Next, H2S is a toxic gas with a rotten egg smell, and it is used for the qualitative analysis. Solubility of water is given to you 0.195 molar. Then calculate the Henry's law constant, that is KH is asked. Now according to the equation, molality is given to you. So that we will write the meaning of it. It means 0.195 mole of H2S is present in 1000 gram of solvent. So that number of moles of H2S, it is 0.195, and number of moles of water, it will be 1000 by 18, it is 55.55. So that the mole fraction of H2S, it is number of moles of H2S divided by H2S plus NH2O. Now all the terms are known for us: 0.195, All the terms are known for us. 0.195 divided by 0.195 plus 55.55. So final answer of it is 0.00349. So now according to Henry's law, pressure equals kh into x. Here at STP, pressure will be 1.013 multiplied by 10 raised to 5 Pascal. That will be 1 bar. So that kh will be pressure by mole fraction of H2S. Pressure is 1 bar and it is divided by 0.00349. And by division we are getting the answer. So answer is 286.5 bar. Henry's law constant for the CO2 in water is given to you at 298 Kelvin. Calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atmosphere CO2 pressure at 298 Kelvin. So here you are given KH 1.67 into 10 raised to 8 Pascal. Pressure of CO2 2.5 atmosphere. Here unit is Pascal. So now we will convert it atmosphere into Pascal. So it is multiplied by 2.5 into 101,325 Pascal. Next, molar mass of CO2 is 44 gram per mole. So according to Henry's law, pressure equals kh into mole fraction of CO2. So that mole fraction of CO2 equals pressure upon kh. Pressure is 2.5 upon kh 1.67 into 10 raised to 8. So the mole fraction is 1.517 multiplied by 10 raised to minus 3, and it has no unit because mole fraction is unitless. Now you are asked that in a 500 ml of soda water we want to calculate the quantity of CO2. So 500 ml, that is 500 gram of solution, and the reason for it is here not given into the question, but we have to assume that density of solution is 1 gram per ml, means 1 ml has 1 gram, so 500 ml has 500 gram. Next, so number of moles of water will be 500 divided by 18, and it is 27.77, so that is 27.78. So that mole fraction means number of moles of CO2 upon total moles. Now number of moles of CO2 will be negligible because its mole fraction is so much less, so at denominator it will be neglected. So n of CO2 upon n of H2 is 1.517 multiplied by 10 raised to 3. So that number of moles of CO2 will be multiplication of 1.517 into 10 raised to minus 3 and 27.78. And we are getting the answer 42.14 multiplied by 10 raised to minus 3 mole. So that the mass will be mole into molecular mass. So 42.14 multiplied by 10 raised to minus 3, and it is multiplied by 44, and final answer is 1.854 gram. This is the final answer. The vapor pressure of pure liquids A and B are 450 and 700 mmHg respectively. Means the vapor pressures of two liquids are given to you which are in pure state, and find out the composition of liquid mixture if the total vapor pressure is 600 mmHg, and also find the composition in vapor phase. So here P total is given to you 600 mmHg, and P0A and P0B are given to you. So according to Raoult's law, for the liquids is P total equals P0A XA plus P0B XB. And here we can write P0A XA plus P0B. We know that the total number of mole fraction, total mole fraction will be always 1. So in place of XB, we can write 1 minus XA, and here P0A XA plus P0B minus P0B XA, that is equal to P total. So P total is 600 equals 450 into XA plus P0B is 700 minus P0B is 700 XA. So first of all 700 is shifted towards the left hand side. So 600 minus 700, that will be minus 100, and here 450 is subtracted, 450 XA minus 700 XA. So subtraction value will be minus 250 XA. So that XA will be minus 100 by minus 250. This minus 250 is shifted towards left hand side, so it will be a denominator, and here XA will be 0.4. So that XB will be 0.6. How? 1 minus 0.4. Okay, so this one is the composition, that is the mole fraction of liquid A is 0.4 and mole fraction of B is 0.6. Now in vapor phase also composition is asked. So according to Dalton's law, formula is Ya into P total equals P0A XA, so that Ya will be P0A XA divided by P total. P0A 450, XA 0.4, divided by P total 600, and by division we are getting 0.3, and YB will be 1 minus YA, 1 minus 0.3, so finally it is 0.7. So YA and YB are the composition in vapor phase. Next, vapor pressure of pure water at 298 Kelvin temperature is 23.8 mmHg. 50 gram of urea is dissolved in 850 gram of water. So to calculate the vapor pressure of solution of water for this solution and its relative lowering. So for that, W2 mass of solute is given to you, 50 gram. Next, M2, it is 60. W1 is 850 gram, and M2, M1 is 18 gram per mole. Here the unit is gram per mole. Now, number of moles of urea, N2 will be 50 by 60. So it will be 0.83 mole. And number of moles of solvent, it is 850 by 18. It is 47.2 mole. So that the mole fraction of urea will be 0.83 divided by sum of number of moles of solute and solvent, that is N2 and N1. So finally we are getting 0.017. Now according to Raoult's law, relative lowering in vapor pressure, that is P10 minus P1 upon P10, that is equal to X of solute. So first answer is formed, that is relative lowering in vapor pressure, it will be 0.017, and it is unitless. And now you are asked the vapor pressure of water, that is the solution. That means P1 is asked. Now P1 is differentiated, P10 is differentiated, so 1 minus P1 upon P10. So it is divided to here and here at both of the terms. So that 1 minus 0.017 equals P1 upon P10. So P1 equals, by subtraction we will get 0.983, and it is multiplied with P10, that is given to you 23.8 mm, and by multiplication we will get 23.4 mm. This is the answer. Next is boiling point of water at 750 mm Hg is 99.63 degrees Celsius. So how much sucrose is to be added to 500 gram of water so that it boils at 100 degrees Celsius? Means this one is the TB and this one is this one is TB and this one is T0B. So both are known for us. So delta TB, it is a subsection of boiling point of solution minus boiling point of pure solvent. So 100 minus 99.63, it is 0.37 degrees Celsius. And simple formula is applied. Elevation in boiling point equals Kb W2 1000 divided by M2 into W1. Kb is 0.52. Here Kb is not given to you. 0.52 Kelvin kilogram per mole. Multiplied by W2, that is asked, into 1000. M2 sucrose 342, it has molecular mass, and W1 500 gram, and delta TB 0.37. So that W2 equals 0.37, 342, 500, 0.52 and 1000, and answer is 121.7 gram. Next, calculate the mass of ascorbic acid, vitamin C, C6H8O6, so that molecular mass can be calculated, to be dissolved in 75 gram of acetic acid to lower the melting point by this one. So directly you are given this delta TF, acetic acid mass of solvent, that is W1, and mass of ascorbic acid, that is W2, is asked, and Kf is also given to you. So simple, we will apply the formula Kf equals W1 M2 delta TF by W2000. First of all, whenever any acid is dissolved in water, at that time it will be ionized. But here one short note should be written, that ascorbic acid is not ionized. So that N factor, means want of factor, will be 1. Now we have to make a subject to W2. So W2 is shifted here, Kf is here. So W1 M2 delta TF by Kf 1000. W1 75, M2 molecular mass is 176, delta TF 1.5, Kf 3.9 multiplied by 1000, and by division we will get 5.077 gram. Next, calculate the osmotic pressure in a pascals exerted by a solution prepared by dissolving 1 gram of polymer of molecular mass 185,000 in 450 ml of water, and temperature is given 37 degrees Celsius. So simple formula will be applied. Pi equals W2 RT by M2 multiplied by V. Okay, now here W2 is 1 gram. R, unit of R will be 0.0821 liter atmosphere per mole per Kelvin. T temperature 37 plus 273 So it is 310 Kelvin. M2 molar mass is given to 185,000 gram per mole, and V volume is 0.45 liter. So all the terms in a desired unit. So W2 1 gram 0.0821 310 185 000 0.45, and so by calculation we are getting 0.000306. Okay, this much atmosphere. It is multiplied by 10 raised to 5, then 1, 2, 3, 4 and 5. Then answer is 30.6 Pascal.